Amazing people, we're going to deal with some examples of where we apply trigonometry to find sides. Now, in this first example, we've got a triangle which has a hypotenuse side of 15.6 meters. We've got an angle of 35 degrees and 26 minutes. And then we've got another side which we need to find, which is W meters. Now, one of the first key aspects we want to do here is identify what our sides are that we have. So we've got our hypotenuse up here because it's across from the right angle. Then we've got our angle, which is here, but we also need to identify the relationship of this side to that angle. Now, in respect here, what we have is we have an adjacent angle because it's right next to it. So this is going to be adjacent here. So based on this, what we're going to use is we're going to use the cosine ratio. So in this case here, what we've got is we've got cos theta is going to be equal to adjacent over hypotenuse. Now, in this instance here, we substitute each of these values that we have here, and we'll find the length of that side, which is labeled as W meters. So this is going to be cos 35 degrees, 26 minutes, and this is going to be equal to W over 15.6. Now, from here, we can rearrange the formula here to make W the subject. So what I'm going to do is I'm going to multiply both of the sides here by 15.6. That's going to move that 15.6 to the other side and leave just W by itself. And so what we're going to have then is W is equal to 15.6 times cos 35 degrees and 26 minutes. Now, from here, what we do is we need to type this into our calculator here. So using the calculator, we're going to type 15.6 times cos of 35 degrees, 26 minutes. I'm just going to close the brackets here and press equals. And we can see that we get an answer here for W, which is 12.71073 and so on. Let's round this to 2 decimal places here. So we're going to have 12.71. This is meters, and we just need to make a reference that this is to 2 decimal places. In this next example now, we've got another right angle triangle, and we want to identify each of the sides that we have here. So first of all is we've got the hypotenuse side, so that's going to be k centimeters. So this is going to be our hypotenuse here. Now what we need to do is we need to identify the other side that we've got, which is this 12 meters, and its relationship to the angle over here, which is 67 degrees and 8 minutes. Now, in order to do that, if we look here, it seems to be across from it. So this is going to be the opposite angle that we've got here. Now, based on that of opposite and hypotenuse, the ratio we're going to use is we're going to use sine theta is equal to opposite over hypotenuse. That's the one we're doing here. So we're going to substitute these values into it. So we're going to have sine of 67 degrees and 8 minutes. That's going to be equal to 12 over k, because that's the side we're finding here. Now, what we need to do is we need to rearrange this. So what's going to happen is I'm going to multiply both sides by k first, and that's going to give me k times sine 67 degrees and 8 minutes is equal to 12, but that doesn't make k the subject yet. So the next thing I need to do is I also need to divide by sine 67 degrees and 8 minutes on both sides. Now, based on that, I do have k as the subject now, and k is going to be equal to sine 67 degrees and 8 minutes, and that's underneath the 12. So from here, what we then need to do is we need to be able to type this into our calculator to work out the value of k. On a calculator here, that's going to be 12 over sine 67 degrees and 8 minutes. I'm going to need to close the brackets here, and that's going to give me 13.02. We've got k is equal to 13.02, and that's rounding that to 2 decimal places, and that's going to be centimeters, and we just make a note of that here. Now, in this example here, we've got another triangle to deal with here. We need to identify each of our sides here. So this one, we can see that we don't have the hypotenuse. So the hypotenuse has been left blank in this instance. What we need to do is identify from this angle here what the sides that we have are. So based on this, first of all, let's deal with the numbered side. So if we go across from here, it appears to be opposite. So that's going to be our opposite side, and therefore with the x being right next to the angle, that's going to be our adjacent side here. So the ratio we're using in this instance is going to be the tan ratio. So it's going to be tan theta is equal to opposite over adjacent in this instance. Substituting the values we've got into this, what we're going to have is tan 55 degrees and 34 minutes. And that's going to be equal to opposite over adjacent. So it's going to be 35 over x. Now, what we need to do is we need to rearrange it to make x here the subject. Now, what we're going to do is we're going to multiply both sides by x, And once we move that x to the other side, we can divide by the tan ratio. But what you might notice is effectively these two values are just swapping their places here. So as we swap them, what we end up with is x is equal to 35, and that's going to be over tan 55 degrees and 34 minutes. So from here, what we do is we type this into our calculators. So we're going to have 35 over tan 55 degrees, 34 minutes, close the brackets off, and that's going to give us 23.9949. What I'm going to do, I'm going to round this to nearest whole number. So this is going to be 24. Okay, this is going to be millimeters. And in addition to this, I'll just make a note that this is to 0 decimal places in this instance.